Good morning. Today we are going to start a unit in which we talk about parallel and perpendicular lines. We are going to focus very specifically on parallel lines and the relationships that can be created between parallel lines. And so let's jump in. I wanted to first revisit some vocabulary that I hope you are already comfortable with. We have parallel lines. Those are lines that you learned about in Algebra 1. They are in the same plane. They do not intersect, which means that they have the same slope, rise over run. They have the same slope and different y-intercepts. I drew a picture of them over here. It's lovely to have pictures. And two vertical bars set next to each other is our symbol or the marking that is used to indicate parallel lines. You can also see parallel lines indicated by arrows drawn on the actual lines. So that's another way to see it visually. There's something called skew lines. We don't spend much time with skew lines, if at all, but it's valuable for you to understand what they are. Skew lines do not lie in the same plane. They are not parallel. They do not intersect. My analogy is maybe the left side of a tissue box and then the bottom edge on the opposite side. And I don't have a box with me right now to show you, but you can grab one and see if you can identify the skew lines. There's also something called parallel planes. Again, something we don't talk an awful lot about, but it's important to know. Parallel planes would be the left and the right side of a tissue box, or perhaps the ceiling and the floor of your house. We hope those don't intersect because that seems like that would be problematic. And those are just some examples of parallel planes. The last thing I wanted to revisit was a transversal. And a transversal is a line that intersects two or more lines in a plane at different points. I labeled my transversal T for transversal. And I have that transversal T is intersecting line L and line M at different points. Sometimes we will know that line L and M are parallel to each other, but we can't assume that. We need to be given some specific information about that because it changes the relationships between the angles. So let's just look at an example. I have a picture here that I have drawn, and I highlighted different parts of it to just so that we can familiarize ourselves with finding the different parts of a prism or a figure. In this case, it's asking me what lines might be parallel to line AB, which I drew in orange. And I went ahead and identified other lines I thought were parallel to AB, and those were DC and EF. Those are not the only parallel lines in this diagram, however. The bottom is parallel to, on the bottom left, parallel to bottom right. My back sides are also parallel lines. I highlighted those in blue. And then the last set of parallel lines would be DA and CB, and I colored those in purple. I don't know that you can see that as well as I can, but those are the sets of parallel lines. There are lots of skew lines in this diagram. For instance, DE is going to go forever in up or down, depending on how you want to think about this, but it will never intersect line AB. And then lastly, with any prism, there are always two parallel planes. Those are considered the bases. We cover that in Unit 12. The bases, or the parallel planes in this particular diagram, would be plane DEA and plane CFB. So that's how we can just use our vocabulary to help us identify parts of a figure. Fascinating stuff, don't you think? Life gets a little bit more interesting when we have two lines cut by a transversal, because there are lots of different angle pairs that are created by this. These are angle pairs that you have seen before. This is just to refamiliarize yourself with them. We have alternate interior angles. I like to think of them as being inside the parallel lines, but on opposite sides of the transversal. We have alternate exterior, which means that they're on the outside of the parallel lines, but on different sides of the transversal. Same side interior angles are on the same side of the transversal, both inside the parallel lines, same side exterior, on the same transversal outside the parallel lines. The tricky one for most of my students to remember would be the corresponding angles. And these are just angles that are in the same relative position in the diagram. What I have done in my diagram is I colored in the vertical angles, orange, the one that went from left, top left to bottom, to bottom right, top left, bottom right. Those are orange. And then my top right, bottom left are blue vertical angles. And what I notice is that my alternate interior angles and my alternate exterior angles and my corresponding angles will all have the same color representation, and that's important there. It's a visual cue that helps me understand their relationship. And then my same side interior and exterior angles, when highlighted this way, will have different colors. I believe that there is a possibility that in previous years you heard these angle relationships referred to differently. And I'm trying to think what that is. Consecutive interior angles or consecutive exterior angle, perhaps. We typically refer to them as same side interior, same side exterior. That's just the nomenclature that we use. But if you have previous knowledge of consecutive angles, then the relationships transfer. With example 2, what I would encourage you to do is pause the video and see if you can identify the different types of angle pair created in this picture, and then which transversal actually created that angle pair relationship. I highlighted my different transversals. There are so many different sets of different sets of lines cut by transversals here. It's a little nutty. And there's 4 potentially different transversals that can create some angles. So pause this and take a moment to identify those, and then rejoin us to see how successful you were. All right, here's what I came up with. Again, corresponding angles are sometimes the hardest to identify. They will be in the same relative position. I noticed that angle 1 is top left, angle bottom is top left of this angle cluster. And so they are in the same relative position. They are created by the transversal C, their corresponding angles. And then I did a similar process for the remaining angle pairs. The next thing we're going to talk about are the types of angle pairs and whether these angle pairs could be congruent or whether they could be supplementary. This is my abbreviation for supplementary. I went ahead in this picture and did what I described previously. I identified my vertical angles going from top left, bottom right, top left, bottom right, and I made those the same color. I did the same thing with my vertical angles going this direction. And then what I'm going to ask y'all to do is I'm going to ask you in a moment to pause the video and see if you can fill out this table. What I'd like you to do is identify the angles, angle 1 and angle 5. These are both on the top left of a line, and it's transversal, so top left of this cluster, top left of this cluster. Therefore, I dub those to be corresponding angles. I believe that corresponding angles are going to be congruent and not supplementary. If we are in class, then we have a way to draw this picture on what's called it's like parchment paper or patty paper, and then we can discover the angle relationships ourselves by playing around with that piece of paper. If you're watching this video from home and you have some tissue paper, and you could trace this figure onto the tissue paper and then move it around to see what the angle pair relationships are, I encourage you to do that. If you do not have that tissue paper at home, then feel free to just take it on faith that these are the angle pair relationships that are created in this picture, and this is their either they're yes or no that they are congruent, yes or no that they are supplementary. And again, I invite you to notice that in my picture, when the colors are the same for my angles, then they are congruent angles. And when my colors include one of each, then they are not congruent, but rather they are supplementary. We can generalize this picture and make some conclusions. We can say that the types of angles that are congruent when the lines are known to be parallel are corresponding angles, vertical angles by definition, and alternate interior and alternate exterior angles. Those angles which are supplementary when we have parallel lines are linear pairs. By definition, a linear pair will always be supplementary, but additionally, same side interior and same side exterior angles are also supplementary when you have parallel lines. The next table is asking you to do that same exercise by which you transfer this diagram onto a piece of tissue paper and then try transposing that tissue paper over this image and seeing what the angle pair relationships are, whether they are congruent or supplementary. What I hope you notice in looking at this table or through your investigation is that when the lines are not obviously parallel, or I was not told that they were parallel, then there are fewer congruencies and fewer supplementary angle pairs. In fact, I think you could go so far as to say the only angle pairs that are congruent in this diagram are the vertical angles, and the only angle pairs that are supplementary in this diagram are the linear pairs. From that, I think we can conclude that because here in the first table, the parallel lines, that we had some additional angle relationships. And that if we don't know that lines are parallel, we can't conclude those same things. Regardless of parallelism, vertical angles will always be linear, pairs will always be supplementary. Those are some just general things that we can walk away with. Let's finally look at an actual example. So in this example, how to hide things. I went ahead and again colored in my figure. You can use highlighters for this as well. In this figure, I am shedding and I have hair floating around on my paper. Sorry about that. In this figure, I'm looking at angle 1, top left, and angle 5, bottom right. I noticed that immediately that they are both on the outside of the parallel lines. These lines are parallel because the arrows are used to indicate that. I also noticed that 1 is on the left-hand side of the transversal T, 5 is on the right-hand side. Thus, I conclude that they are alternate exterior angles. I know from my investigation that alternate exterior angles are congruent. Therefore, I can conclude that the measure of angle 1 will be equal to the measure of angle 5. I can go through the same process for angle 2 and angle 3. In my head, I ask myself, are they on the same side of the transversal? Yes, they are. And are they both inside the parallel lines? Yes, they are. So they are same side interior angles. And I know from my investigation that same side interior angles are supplementary. And by the definition of supplementary, I know that the two angles will together add up to 180. All right, the last example that we're going to do today is looking at yet another set of parallel lines cut by transversals. Notice in my picture, I'm not given any arrows to indicate parallelism, but in my prompt, I was told that L is parallel to N. And if you felt comfortable, you could draw those arrows onto your diagram to indicate that parallelism, just if that makes your brain happy. I went ahead and again identified my vertical angle pairs and highlighted those. That gives me some visual information. I'm asked to look at angle 3, which is here, and I'm told that it's 115 degrees. I'm asked to use that information to find the measure of angle 5. So the first thing I notice is that they're both blue angles as my picture's drawn. So therefore I can hint, or I can try to prove or try to verify that they are congruent angles because they're the same color. Sorry, grappling for words there. I notice they're both inside my parallel lines, and I notice that they are on opposite sides of the transversal. So I conclude that these are alternate interior angles. Therefore, angle 3 is congruent to angle 5. And by the definition of congruency, I know that their measures are also equal. I can do the same thing for angle 8 and angle 2. They are outside the parallel lines and on opposite sides of the transversal. Therefore, they are alternate exterior. And I can conclude from the definition of alternate exterior tells me that actually that's not true. There's an alternate exterior theorem that we will investigate soon that tells me that angle 8 is therefore congruent to angle 2. And by the definition of congruency, I know that their measures are equal. Lastly, I'm asked to look at angle 4 and angle 7. The first thing I notice is that angle 4 is inside the parallel lines, angle 7 is outside. They are on different sides of the transversal, so they are neither same side interior, exterior. They are alternate, but they're not both interior or exterior, and they're not corresponding because they're not in the same relative position. So these two angles have absolutely no relationship whatsoever. However, I know that angle 4 and angle 6 are congruent. Those are alternate interior angles. And I know angle 6 and angle 7 form a linear pair and are therefore supplementary. And if I use substitution, I can say that angle 4 plus angle 7 are supplementary. Transitive, substitution, I would argue actually that this is substitution, not transitive. We'll learn more about that later. And once I know that angle 4 and angle 7 are supplementary, I can subtract the measure of angle 4 from 180 and conclude that measure of angle 7 is 133 degrees. That one takes a moment to digest. So explore it, think about it, do the math, and come to me if you have any questions. Until next time, have a swell day.